Let's discuss the optimal main circuit breaker selection for your distribution panel. You're designing a panel to power 4 air compressors, each with a 175 amp starting current using a star delta starter and 85 amps running current, plus 2 vacuum generators. One vacuum generator draws 52 amps starting and 18 amps running, the other draws 50 amps starting and 13 amps running. The compressors are switched on sequentially, with one acting as a spare, while the vacuum generators start first. You're considering a 400 amps versus a 600 amps main breaker, with a calculated steady-state current of 286 amps. We have two options to consider. Option 1, a 400 amps main circuit breaker. This option offers advantages such as 1. Being adequate for the calculated steady-state running current demand of 286 amps. 2. A more economical choice compared to the 600 amps breaker. However, there are disadvantages as well, such as 1. It may not provide sufficient headroom for the high starting currents of the compressors. Option 2, a 600 amps main circuit breaker. Advantages of this option are 1. It provides ample headroom for starting currents, ensuring reliable operation. 2. It future-proofs the system for potential load increases or equipment upgrades. Disadvantages would include 1. It is more expensive than the 400 amps breaker. Based on your design and the starting current requirements, the 600 amps main circuit breaker is the preferred choice. Here's why. The starting current of a compressor on a star delta starter can be significantly higher than its running current, potentially 6 to 8 times the running current. In your case, each compressor has a 175 amp starting current. If all 4 compressors were to attempt to start simultaneously, though unlikely given your sequential starting scheme, the potential inrush current could be substantial. While only 3 compressors will operate concurrently, a 400 amps breaker may still be insufficient to handle the combined starting current without nuisance tripping. A 600 amps main circuit breaker provides a larger safety margin, ensuring reliable operation even during the starting of multiple compressors. Remember, selecting a main breaker involves more than just the steady-state load calculation. The inrush current requirements of motors and other inductive loads are critical for a reliable system performance. Further considerations: the individual circuit breakers for the compressors and vacuum generators should be sized appropriately to handle their respective starting and running currents. Ensure proper coordination between the main circuit breaker and the individual branch circuit breakers to provide selective tripping during fault conditions. This means that a fault on a branch circuit should trip only that breaker, not the main breaker, preventing a complete shutdown. Use appropriately sized cables and other protection devices throughout the distribution panel to ensure safety and reliability, following relevant electrical codes and standards such as the National Electrical Code.